Hey there. We're going to be looking at the derivative of the natural logarithmic function f of x equals ln of x in this video, and then the integral of 1 over x. So let's start with f of x equals, if f of x equals ln of x, the derivative of that, f prime of x, is equal to 1 over x. So this is something that you want to put in your notes, and we're going to use this fact to differentiate different functions that involve the natural logarithm. All right, all the rules for derivatives apply: the product rule, the quotient rule, chain rule. So for example, if we were going to find the derivative, I didn't write that, but let's find y prime for this function y equals ln of x times sine of x. So hopefully you recognize that this is a product, and so our y prime is going to be u prime v plus u v prime. And so my u will be the first factor here, which is ln of x, and then u prime, remember we just wrote this down, is 1 over x. And then for v, I have sine of x, and v prime is cosine of x. So we're going to throw it into this formula here. So my derivative, y prime, is 1 over x, that's my u prime, times v, so times sine of x, plus u, which is ln of x, and then v prime, which is cosine of x. I can clean that up a little bit by putting sine of x over x plus ln of x cosine times cosine of x. All right, let's look at another example. So we're going to find f prime of x, find the derivative. So we have a quotient, so recall that the quotient rule says if I have a quotient, I'm going to go u prime v minus u v prime over v squared, where u, again, is ln of x, the numerator, u prime, 1 over x, my v is the denominator, x squared plus 3, v prime is 2x, and then v squared is this quantity squared. And I would leave it like that. Don't FOIL that. Don't multiply x squared plus 3 times x squared plus 3. Just more work for yourself. Sometimes you might need to, but oftentimes you won't want to do that. Okay, so I have to do u prime, which is 1 over x, times v, which is here, x squared plus 3. And then I have minus, I'm going to need to move this over. Minus, from the formula, u, which is ln of x, and then v prime, which is 2x. Now be careful, the ln, you're taking the argument of the natural log there is just x, and then you're multiplying that by 2x. So sometimes I'll just move that 2x to the front so it's not confusing. And then this entire thing over v squared, which is x squared plus 3 quantity squared. So there's your derivative. You could clean it up maybe a little bit, but there's not a whole lot that's going to simplify in here, so I'm just going to leave that for now. That's just algebra skills from there. So let's look at another one. Here we're going to need to use the chain rule, and also the constant. We have a constant times a function here, so we're going to, when we find the derivative, find y prime, find the derivative, we're going to keep the constant there and multiply by the derivative of the function ln of x cubed plus 4x. So the outside function here is the natural logarithm, so it's going to be, and so if you think of this as ln of u, then it's going to be 1 over this inside function here. So I'm applying the chain rule. So this is like when you're taking the derivative for the natural log, it's going to be 1 over whatever the argument is, and then you have to multiply by the derivative of the inside if there is something other than just an x in there. Okay, so I'm going to have 5 times 1 over x cubed, you leave the inside alone, times the derivative of the inside. So that would be times 3x squared plus 4. And this one I do want to kind of put together here. If I put all of these over 1 and multiply straight across, I'm going to get 5 times 3x squared plus 4, which you can distribute the 5 if you so desire, over x cubed plus 4x. So there's your derivative. All right, let's try one more. I want you to pause the video and do this one on your own, and then come back and watch the solution. So first thing you want to do, and what we're doing here is we're going to find the derivative. So find f prime of x if f of x equals the square root of ln of the quantity x squared. First thing you want to do is rewrite your radical this to the 1/2 power. So we're going to need to use the chain rule, drop that 1/2 down, use the power rule to for the first part of the chain rule. So bring the 1/2 in the front, and then leave that inside alone. So ln of x squared is going to stay ln of x squared. And then subtract 1 from your exponent, so to the negative 1/2 power. And then now we're going to take the derivative of this inside piece, which is ln of an argument of x squared, so we're going to have to do the chain rule again. But we're going to take 1 over x squared, because remember the derivative of ln of x is 1 over x, or if it's ln of u, if it's a function of x, then you just do 1 over the argument, which is in this case x squared. And then we still have to multiply by the derivative of the inside, which is x squared, so the derivative of x squared is 2x. Okay, so again, putting that, if I put that over 1, I'm going to bring this to the denominator because it's got a negative 1/2. So I have, in the numerator, if I multiply across, I'm going to have a 1 times a 1 times a 2x. So I'm going to have 2x in the numerator, and then I'm going to have this 2 from this 1/2 out here. And then ln of x squared, you can put it as a square root, or you can put it as a 1/2 power, and then I'm multiplying by this x squared, which you could put next to the 2 if you want to. So there you go. All right, so this leads me to the integral of 1 over x. Since we just learned that if y equals ln of x, its derivative is 1 over x, it follows that if you were going to find the antiderivative of 1 over x, working that backwards to find the function whose derivative was 1 over x, it would be ln of x plus c. Now there's one little caveat here. When we're doing this, what we need to do is we can only take the natural log of positive values, so we are going to put in absolute value bars around that x so that we can take the natural log of whatever result that we have. Okay, so let's do some examples here. So this is a definite integral, and the function, the integrand, is 1 over x. So it's going to be ln, and we're going to put absolute value of x, and we're going to integrate that from 1 to 2. So just like normal definite integrals, we're going to plug in the 2 first. So we have ln of 2. I can drop those absolute value bars because 2 is greater than 2 is already positive. And then I have minus ln of 1. And now what is ln of 1? It's 0 because the base of ln is e. So e to what power equals 0? Well, e to what power equals 1, I mean. E to the 0 equals 1. So this whole term back here is 0. So this answer is just ln of 2, the area under the curve of the graph of 1 over x, which if I draw that graph really quickly here, 1 over x is a rational function. And so if I'm finding the area under the curve from 1 to 2, it's simply equal to ln of 2. And in fact, that's true for anything. If you're finding the area under the curve of 1 over x from 1 to any value, it will always equal ln of that upper limit of integration if the lower limit is a 1, because we'd end up with ln of 1, which is 0, so it just end up being ln of whatever that upper limit is. Okay, so let's look at another one. This one doesn't come jumping at you right away as a natural log function, but if you try to integrate this, there's no quotient rule that we can use. You can't take the antiderivative of the numerator and the antiderivative of the denominator. That doesn't work. You can't split it up. So we try to do u substitution, which we learned recently. Think about what u would be so that its derivative is a piece of the integral. And hopefully you're thinking x cubed plus 2, that denominator. So then du, the derivative of that, with respect to x, is 3x squared dx. So I have a x squared in the top. If I make that a 3x squared, then I'm getting somewhere. But if I put a 3 in front of this, because I want it to match this, if I put a 3 here, I need a 1/3 on the outside. So I'm going to go 1/3, and then I'm going to split this up to see it more clearly. I have 1 over x cubed plus 2 times 3x squared dx. If I multiply it across, I'd get what I started with there. So this is my u, right? This is equal to du. So I can rewrite this as 1/3 1 over u du. So now I'm integrating 1 over u with respect to u, and then I'll sub back in what I get in terms of x here in a minute. So I have 1/3, and remember the antiderivative of 1 over u is ln of u in absolute value, and I'm going to have plus c because this is an indefinite integral. Put back the function in terms of x, and you get 1/3 ln of x cubed plus 2 in absolute value bars plus c. A lot of times when you're doing applications, you'll be able to drop the absolute value bars because we're going to just be dealing with populations of people or time, and it'll be positive anyway. But this is how you would do this, the integrals. Okay, so the next video we're going to look at the natural, we're going to look at exponential functions and how to find the derivative of those and antiderivatives.